Hello everyone, welcome back to ANR Academy. This is Nepal Reddy sir. Today I am here with you to discuss about 9-point circle. This circle is also called as Euler circle, and 9-point circle is possible for any triangle. Suppose if there is a triangle ABC, clearly the 9 points are specifically they are middle points of sides of the triangle, so that you will get 3 points like that, and another 3 points they are feet of altitudes, total 6 points over. Remaining 3 points they are middle points of line segment joining orthocenter to angular points. Let us see in this figure. See here, given there is a triangle. Observe the figure. Red colored marked points, they are middle points of 3 sides. Next, yellow colored, if you observe, they are feet of altitudes. Next 3 points, they are middle points of line segment joining here orthocenter to angular point. 1 point here, another point here, and the last point. So these are the 9 points with respect to given triangle. Specifically, the circle which is passing through these 9 points is known as 9-point circle. Here red colored indicates middle points of 3 sides. 9 points I am going to write. First 3 they are midpoints of 3 sides of given triangle. Next, yellow colored points, they are feet of altitudes. Feet of altitudes drawn from 3 vertices. Next, white colored points, if you observe on the figure, they are middle points of the line segment joining orthocenter to angular point. Orthocenter here O. So next 3 points I am going to write. They are midpoints of line segment joining orthocenter to angular points or vertices. So clearly sides of middle points 3, feet of altitudes 3, remaining 3 middle points of line segment joining vertices to orthocenter, right? Total 9 points. Specifically, the circle which is passing through these 9 points is known as 9-point circle. Next, let us see this figure. There is a triangle and orthocenter, circumcenter mentioned in the figure. Clearly, the 3 sides of the triangle, they are secants with respect to this circle. Why? Because each side cuts the circle at 2 different points. Here, 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 and here. And this is circle S. Sorry, this is circumcenter S, and this is orthocenter O. The same figure what you have in the previous, just these 2 points and these two selected in this figure. Only 6 points here mentioned, and next 3 points actually they are middle points of line segment joining vertex to orthocenter. So here Next, vertex to orthocenter, middle point here, vertex to orthocenter here. See, except these 3 points, remaining 6, they are point of intersections of circle with respect to given triangle. And clearly the lines which you have sides of a triangle, they are acting as secants with respect to this circle. Suppose that if you draw perpendicular bisectors with respect to all the 3 secants, what happens? Observe. Here I am going to draw a perpendicular bisector. Next, one more perpendicular bisector here. Another perpendicular bisector here. We know that perpendicular bisector of secants always passes through center of the circle. So that this is known as center of the circle. Notation I am going to write capital N. And let us observe the figure. N divides the line segment joining orthocenter and circumcenter in the ratio 1:1. It is very clear in the figure. N is midpoint of line segment joining orthocenter and circumcenter, remember. Next, see here, ONGS is there. Oil, natural, gas, system. Actually, O indicates orthocenter. Here O is orthocenter. Just for remembrance, it is written oil, natural, gas, system. O indicates orthocenter. Next, N indicates 9-point center. Next, G indicates centroid of the triangle. G is indicating centroid. Next, S is nothing but circumcenter. S indicates circumcenter of the triangle. But it is easy to remember oil, natural, gas, system. Observe, there is a 9-point circle with respect to a triangle, and if you mention circumcenter, centroid, 9-point center, orthocenter, the 4 points which lies on same straight line, so that they are called collinear points also. Remember, they lies on the same straight line, so that they are called collinear points. And you know that centroid G divides the line segment joining orthocenter and circumcenter in the ratio 2:1. And 9-point center, which is middle point of line segment joining orthocenter and circumcenter. Let us discuss the ratio in which N divides OG, N divides OS, G divides OS, G divides NS. Let us discuss now. Yes. You know that O orthocenter, S circumcenter, middle point of these two N, and you know that G, it divides the line segment joining orthocenter circumcenter in the ratio 2:1, so that here you have to mention G. Now this is the order. Depending upon the shape of the triangle, whatever the shape of the figure, see here in this first figure, if you observe, you will get O first and then N, after that G, and after that S. But if you have the figure in this model, then you have O here, N, G, S. Maybe in this direction from left to right or from right to left starts with O, N, G, S. It is very easy to remember O, N, G, S. Yes. See the ratio in which N divides OS, G divides NG, whatever it is. We know that N is middle point of line segment joining orthocenter and circumcenter. This is middle point. So that I am going to write the ratio T is to T. 1 is to 1. That is 1 multiple, 1 multiple. You know that ON by NS equal to 1 by 1. Therefore, I am writing ON is 1 multiple, NS is also 1 multiple. Okay, next. And you have centroid G divides OS in the ratio 2:1. G divides OS in the ratio 2:1. Therefore, OG 2 multiple, GS that is 1 multiple. Yes, from here to here, assume that this is 2 lambda, and G to S, assume that is some lambda. Centroid 2:1 ratio, 9-point center 1:1 ratio. But our aim is to find O to N, N to G, G to S. The ratio that is ON by NG by GS. Suppose that this is some A and B and this is C. Yes. The entire length, total length, I am going to select some O to S. The length I am going to select some X. Now observe, first A. A you have T. Next C. C you have lambda. Next B. From T, if you remove C, you will get B. From entire T, I am going to remove C. T minus C it is. But C is clearly lambda. So T minus lambda, lambda you got. Now, I am going to select the relation between lambda and T. The entire O to S, the length, suppose that is small x. That is 2 lambda plus lambda is x. 3 lambda value equal to x, and it is also equal to T plus T. That is 2T. Therefore, here you have the relation T. From this I can write 3 by 2 lambda. Yes, now I am going to write T as 3 by 2 lambda. This is 3 by 2 lambda minus lambda, and this is lambda that can be written as 2 lambda divided by 2. And also here, if you write 2 in the numerator and denominator part, it becomes 3 lambda, next 1 lambda, 2 lambda. So the ratio 3:1:2. So that ONGS, oil natural gas system, orthocenter, 9-point center, centroid and circumcenter, the ratio in which NG divides OS from this line segment, you can remember that O to N, suppose 3 units, N to G 1 unit, and G to S it is of 2. Next, this is about the ratio, and next we go for relation between radius of circumcircle that is formed by given triangle. and the radius of a smaller circle here. Let us observe, which is in red colored. Suppose that this is triangle ABC and this is the triangle PQR. Here PQR, which are middle points of three sides. And observe the figure, triangle ABC, which is similar to triangle PQR. Triangle ABC, it is similar to triangle PQR. So I can write a relation. Radius of circle passing through PQR. Radius of circle, it is passing through the points PQR. Suppose that is small r. Next, I am going to write radius of circle passing through 3 points ABC. That is larger circle, so that radius capital R I am going to write. And you know the relation, when the two triangles are similar triangles, then radius of the ratio of radius of those two circles, it is proportionate to ratio of their sides. Here for bigger triangle I am going to select the side AB, and here corresponding side you have to select QR or RQ. You know that these are middle points PQR, so that the ratio here 1:1. And clearly RQ, which is parallel to AB, and QR is half of AB. I can write small r by capital R equal to RQ by AB equal to, clearly RQ, which is parallel to AB. Why? Because by basic proportionality theorem, by converse of basic proportionality theorem, whenever the two ratios are here 1:1, 1:1, then this line segment QR, which is parallel to AB, and also it is half of AB. So QR is clearly half of AB divided by AB. AB gets cancelled, you will get small r by capital R equal to 1/2, and hence you can write capital R equal to 2 times of R. Therefore radius of circumcircle of given triangle, that is twice the radius of circle passing through middle points of the sides of the triangle. This is about, and also that small r is radius of 9-point circle. Remember, the circle which is passing through middle points, that is clearly 9-point circle. So 9-point center, 9-point circle radius small r, circumcircle radius capital R, and the relation between them capital R equal to 2r. This is about 9-point circle. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.